Okay, here we go. Explaining this. So here we've got our consumption function here, 700 billion plus 0.8y. What we get out of this equation, what we need to do first is we need to explain, or we need to find out what the marginal propensity to consume is, the MPC. And that's actually given to us in the equation by the 0.8, because for every dollar additional that they get, for every dollar that the Y is going up, the consumer is spending 0.8 of it. So the MPC is equal to 0.8. Okay, so we're going to go with that to start to work on this. So it's showing you the answers already, but let's talk about why they are the answers. So how much will the aggregate demand curve shift if there's 50 billion more in government purchases? Well, this part's easy because essentially all we have to do here, will it let me? No, it won't let me write on this. Okay, sorry. It would write the total aggregate demand function is C plus I plus G plus NX. Well, if we're increasing the G here by 50, then it'll just shift by exactly 50. Now, let's look at the tax cut. Tax cut's a little bit more complicated. Here we have to take the amount of the tax cut, 50 billion, and we have to multiply it by the MPC because, right, people are getting this money back, but they're not spending it all. They're spending 80% of it. So it'd be 80% of 50, which is 40. Now, let's look at C. Same thing. Whether you cut a person's taxes and they have more money, or whether the government just gives them more money, like they do with Social Security and whatnot, doesn't make a difference. C is determined exactly the same way. If the government gives people $50 billion, people will spend 80% of it. 80% of 50 is 40. Now we want to know is how much will the aggregate demand function as a total amount change. So now to get the total amount of government spending, we take the 50 billion change and we multiply it by 1 over 1 minus MPC, meaning it'd be 50 times 1 over 0.2. 1 over 0.2 is 5. So 50 times 5 is 250. For the tax cut, we're now doing 40 times 5, which is 200. So multiplying these by the multiplier, these amounts by the multiplier. The multiplier being, again, 1 over 1 minus MPC, or 1 over 1 minus 0.8, which is 1 over 0.2, which is 5. So 40 times 5 here in C is 200. Okay, now let's look at the next one. In the next one, I'm just reading this for the first time here. 300,000 pennies. Oh, that's pretty shitty. Okay, so that's 3,000 bucks. Okay, that's a pretty interesting question. Okay, so $3,000. Banking system has a 3% reserve requirement. How much does the money supply change by? It doesn't change at all because the pennies already existed, right? So initially, the money supply doesn't change at all. Ultimately, at the end of the day, the money supply would change, but that's only as banks lend it out. But the question here is asking about the initial change. So the money supply doesn't change because all we've done is converted currency, which is M1, into a checking account, presumably of the DMV, which is also a M1. So the money supply did not change at all. Total deposits changed by the $3,000 or the 300,000 pennies that were deposited. The total reserves initially would increase by the $3,000 because, right, you'd have both sides of the balance sheet equaling out. But then what happens here is that total reserves are then split into excess reserves and required reserves. Required reserves would be 3% of the 3,000, which would just be $90. Which would then mean that the excess reserves is 3,000 minus $90, which is our 2910. To find the ultimate change in the banking system, how much it would change by, you would need to do 1 over the required reserve ratio, which in this case would be 1 over 0.03, which would be 33 and a third. So then I would take the 2910 and multiply that by 33 1/3. And if I do that, yeah, essentially I get pretty darn close. So 2910 times 33 1/3 gets me 96,990. You don't need to worry about the plus or minus 100. Just if you answered 96,990, you'd be all good. Okay. And then in number 4, here we're just doing, again, another kind of banking system problem here. So if I change the required reserve ratio from 0.2 to 0.15, the total deposits aren't going to change at all. The total reserves aren't going to change at all. But what starts to happen is that the required reserves are going to go down from 20 billion, which is 20% of the 100 billion, down to 15 billion, because now we're down to a 15% required reserve ratio. Then the difference would be how much excess reserves I have. So if I had total reserves of 30 billion, my excess reserves would now be 10, because that would be 30 minus 20. If my reserves were 30 and I subtracted the 15, now I would have 15 billion in excess reserves. This money multiplier of 5 was determined by 1 over 0.2, which is 5. Now it would be 1 over 0.15, which I can confirm is 6.67 or 6.7. But then what we do is we multiply the excess reserves by the multiplier to find out how much the total money supply could have changed had they lent out this extra excess reserves. So it'd be 10 times 5 for 50 versus 15 times 6.7, which is 105. 100.5. Okay, that's it.